Hello, everyone, and good afternoon. I'm sorry for not being able to come to Cyprus for this workshop presentation due to some personal reasons, but I'm thankful to the chairs of this workshop for allowing me to present today via this video. Hopefully, this session would be informative for you. Alright, let's start. So, I'll be presenting my research I did in University at Buffalo while doing my master's, which was predicting latent attributes of an Indian Twitter user. Although the approach can be scaled to a general English-speaking diaspora, but specifically for this work, we have used Indian Twitter users. So here's the outline. So I'll be starting introduction with motivation behind this research and would explain what the problem is and what are the state of the art approaches, and finally what is the approach we have used in this work. I'll then explain the datasets, how we build and use them for feature extraction. I'll be explaining the setup for experiments and the results of this research, and finally concluding the presentation. So as we know, Twitter does not support storing of attributes of a user such as gender, age, or interests of a user. Uh, Such attributes can be used to aggregate demographic information for better user experience and also for targeted advertising. Um, in this particular work, we classified users according to gender, age, or political affiliations. We used observable information such as tweets, which include language-based features and tweeting behavior, with the use of latent information such as what kind of celebrity this user follows and what kind of users on Twitter influence his class. So if a person is male, um, he can be influenced by someone who attracts most of the male users rather than female users. So that was the basic intuition. I'll be explaining these features in more detail in upcoming slides. Um, there are vast applications of this work, such as large-scale polling, the real-time live polling, uh, targeted advertisements, healthcare analytics, recommendation systems, and many more. So, as you can see, there has been some interest in recent years to predict latent attributes of a user. Most of the previous work were heavily based on um, communication patterns, tweeting behaviors, neighborhood features. So, for example, the work we did in this research was highly inspired by Zamal's work on homophily. That is the features extracted from neighborhood, where they tried to predict class of a neighborhood, and with that they tried to predict class of the user itself. This showed promising results in terms of effect of popular neighborhood on the class of the user. They particularly use similar kinds of classes. For example, they try to classify political associativity of a user, what age category the user belongs to, whether the user is male or female. So basically, they all try to do similar kind of work. So This visualization shows how active are Twitter users. You can clearly see that nearly 20% of Twitter users produce zero content, the ones which are in pink. The 50% which are in green are like me, who are lazy and go to Twitter in a week or two. They'll read some tweets, they'll write some tweets, or maybe not. Then there are only few, less than 5% of the Twitter users who have followers followers more than 100, and only 5% of the users produce 75% of the content on Twitter. So this essentially means most of the users who will not produce content would not produce good results with traditional tweet based features, that is just by using tweets. The existing approaches use nearly 1,000 tweets for classifying a user. Uh, so basically, this motivated researchers to focus on non-conventional network-based features. So I have already discussed about Jamal's work, how he used network-based features, like the popular networks, while Lim and Datta, they did some interesting work and tried to use popular users, which are so-called celebrities, to classify users' interest. For example, if someone is following McDonald's, Subway, Wendy's, etc., there is a good probability that the user might be interested in fast foods. So this is one great motivation for us to use popular neighborhood such as celebrities in our datasets as well. What we have done novel in this work are the three things which are following. We used better linguistic content-based features than the simple top keywords, top K hashtags, unigrams. We used LIWC dictionary, the Linguistic Inquiry Word Count Dictionary, to get more specific categories of words for deeper context building. Secondly, we defined a popular neighborhood and then extracted features such as age, gender, and the area in which the celebrity is famous for. For example, Katy Perry is famous for music, while Usain Bolt is famous for sports. Thirdly, we used completely new feature called class influencer, which have shown promising improvements in the accuracy of our results. For datasets, we have created our own database by manually tagging users. For the gender dataset, it was easy to tag users as Indian names are very gender distinctive. Although there are some names which exist which are unisex names, for those cases we have used profile pictures to tag a user if it is a male or female. This allowed us to tag around 300 users, 151 males and 149 females. While age dataset was not that straightforward to create, we created this dataset using a mix of many approaches. We asked random people to fill a survey where we asked some information with their age and Twitter ID. But the number of people who filled the survey was obviously underwhelming, so we tried to tag some users manually. We also tried to find users on other social networks which are also active on Twitter, and that gave us more information about those users, and we could better guess about their age. So for example, if we use LinkedIn, we knew if the person has X amount of experience, we could have guessed that what kind of age category that user may belong to. So, um, but still we fell short of our target of 400 users. We could only um, capture 340 users, uh, out of which 139 were young, that are 18 to 24 years of category. 114 were middle-aged, which are 25 to 34, and then 87 were old, which are 35 plus. For political affiliation, the dataset was easier to create as people are very vocal for the parties they support or oppose. Uh, we also created some datasets to extract features for the users. Um, these were the list of popular users with their age and gender and their area in which they are famous. We extracted this information from Wikipedia and Freebase. While top key class influencers, that dataset was also created by filtering the users which are followed by one class more than the other class, and these users create high degree of skewness in the class. So I'll discuss more about class influencers in upcoming slides. Okay, so now we'll discuss the features we have used in this work. The first set of features are the tweet behavior based features, and these were the basic features used by almost all the state of the art works in this field. These features are tweet frequency, length of the tweet, followers to following ratio, uh, the top K words and top K hashtags for each class. Then there were other frequency based features such as hashtag frequency, retweet frequency, photo posting tendency, link posting tendency. Um, so we have used all these kinds of features which were used by previous works as well. Then we use some of the novel linguistic content based features using LIWC, that is the Linguistic Inquiry and Word Count Dictionary. It helps to categorize unigrams in various categories, thereby using those categories as the features itself. This reduces sparsity in the features as well as build deeper context about the user we are trying to classify. We used 50 distinct categories. Some of these were reference words like I, we, you, he, she, and the parts of speech frequency, which was somewhat like using pronouns more often than any other parts of speech. Um, so we also extracted emotions and emoticons from the text as well as the Unicode based smileys, and categorize them into 5 different categories: the happy, sad, indifferent, naughty, and love categories, and use them as features. Before discussing about popular neighborhood based features, we must first define what is a popular neighborhood or a celebrity for our work. Any user who is either verified or has more than 10,000 followers is a popular user for our work. We found around 9,000 celebrities with the dataset we had. Once we had their names, we tried to extract information using Wikipedia. The informations were which year they were born and the he, she, his, her references. So we found age and gender of the celebrity using this information, and we also used Freebase for finding out the area in which the celebrity is famous for example, acting. So the intuition for doing this is explained in the graph shown here. This study was conducted by belove.com. It's a social media analytics website. Uh, it says that some classes are more interested in some of the areas more than the other class. For example, technology related area had a great skew, where nearly twice the number of males followed this topic than the females. Moving on to class influencers. Top K class influencers proved to be the most important feature for this work. Before moving ahead, let me first define what is a class influencer. So if a user is followed by a certain class much more than the other class, we can say that the Twitter user is a class influencer. For example, uh, Miss Malini, shown here in the slide, who is a fashion blogger, is followed by more than 10% of the users in our gender dataset. While out of those 10%, nearly 80% of her followers were female users. Similarly was the case for Asama Khan, who was followed by nearly 90% of the BJP supporters. Similarly, Alia Bhatt, who is an actress, was highly popular amongst the young people in our age dataset. We'll now discuss the method we use to extract class influencers. First, we extracted all the Twitter users followed by the users in our datasets. These came out to be nearly 500,000 users. Then we filtered these users based on the number of followers they had in our dataset. So if a user is followed by more than 5% of the total users in our dataset, um, they are potential candidates of being class influencer. We further filtered these users based on the bias they induced on each class. For example, a user can only be a class influencer if it shows 70% bias towards a particular class for binary classes and 50% bias for three classes. So once we extracted these class influencers, we used top K of such influencers and used each of them as a feature. I'll now discuss about the experiment setup. We used linear SVM for our work with 10-fold cross-validation. The metrics we used for this paper were precision, recall, accuracy, and we also provided confusion matrices. We added the features incrementally so that we can observe impact of each feature in terms of accuracy. I'll discuss the results in upcoming slide. In this slide, you can see the various configurations of our experiments and the resultant accuracy of each experiment. We can clearly observe that tweet behavior-based features were not as impactful as linguistic features. Celebrities' gender was useful for gender classification, while the famous for category had greater impact on age and political dataset. Class influencers alone proved to be really useful, just that we need to update these influencers periodically. The combination of all these results mentioned above furnished satisfactory results. So, in conclusion, I would say that the class influencers, the class influencer features can prove to be really useful, and we need further experiments to see how effective and robust they are in other datasets. The popular neighborhood features prove to be really easy to extract and can improve overall accuracy of the system. The LIWC dictionary proved to be more useful than simple tweet behavior based features. I would also not forget to mention that all these experiments are done for Indian Twitter users and relies a lot on stereotypical features which may not be true for all kinds of societies. Also, the data set we have created is relatively small. Thus, this experiment would need further investigation on bigger data sets. I would again like to thank chairs of this workshop to let me show my work through this video presentation. I would also like to thank Professor Rohini Srihari for motivating, helping, and guiding me in this research. Also thanks to Nikhil and Surbhi for helping me prepare the dataset and helping me in extraction of some of the features. Thank you everyone for listening to my work. If the network is fine, I'll be on Skype for answering your questions, but you can always send your questions to the email provided here. So thank you. Thanks a lot.